Okay, we had done this to start our lesson today. Number 1 should be changed to a multiply. Number 2, there was something wrong with it. The power here needed to not be a power there. This 3 goes down in front, so it should be right there. Okay, number 3, a divide should be a subtract, not a divide. So it should be subtract log base 10 of y, like that. Next, you could have just reversed these two. There's actually a couple ways you could have done it. How many of you reversed them like that? Okay, that's a good way. Option B is to just say, well, I'm going to leave the problem alone and say that's not the answer. The answer is undefined. That would work. Or how could you make it actually equal 1? What could you put here? A 13. That's another option on how you could have made this a true statement. Okay. And then the last one, that's definitely the hardest one. Do you get that these bases are the same? And therefore the answer is supposed to be right here, but we have this extra complication of that number right there. Well, that number, based on the rules of exponents, could be brought back up onto this x, and now the answer is x to the 5th, like that. Okay, so there is a quick review of common mistakes that people make on log properties. This one, number 1, don't change it first. Instead, find the domain and range first. I hope you remember what that looks like. If you want, make a little sketch for yourself of what that looks like. You know, there's one that kind of looks like a tree blown over in the wind, and there's another one that's the exponential graph. That's like exponential growth kind of graph. Make a little sketch for yourself, and then once you're done finding its domain and range, then convert it to the log that would go with it. So after you've got the domain and range of this, write it as a log. Do the same exact thing on problem 2. And then 3, I think, to be honest, 3 is a little too easy. We're going to skip that one. And 5 is a little too easy also. We're going to skip that one. Just do problem 4. After you're done with 1 and 2, do number 4. I'm going to pause for a minute. Yes, sir. No, that's supposed to be 3 to the x. I agree. That is not written well. Y equals 3 to the x. We're all about the exponentials right now, so thanks for asking. I'll pause while you try those. Picture here. So first, the picture for it, a log, or sorry, an exponential generally looks like that. What would you say its domain was? All reals. And its range?
It would be from
0 to infinity. Can it be 0?
No.
Good. There we go. Good. Okay. Now, if we rewrite this thing as a log, the log of it is going to be the log base 3 of y equals x. Yep. I don't think that you're ready to do that. I would use the 0 with a parenthesis around it. I'm going to spend more time talking about inside limits later. Not today even, it's coming a while from now. But I'm not sure you are a master of that yet. If you want to risk it, go ahead. But all right, on to number 2. Number 2, you should have generally had a picture like this, and then you could ask yourself, what's its domain and range? Because logs look like this. And they have an asymptote running here. And you should have said that the domain of it was from negative and no, it doesn't go to negative infinity. It goes from 0 to infinity. And the range of it goes from negative infinity to positive infinity. You know what? It's kind of like last time, except reverse. And does that make sense? Yes, because logs are inverses of exponentials. The log and the inverse are inverses. If I put this graph right here and this graph right here on the same graph, here I'll do it. They're a reflection over the line y equals x. That makes them inverses. And that's a good thing to note right there. Okay, next thing is to rewrite this log base 5 of x minus log base 5 of y plus log base 5 of z And there's something wrong with what I just did. This is minus log base 5. Oh, you mean this one? So you either need a parenthesis around this whole thing, or you need to distribute that negative. A lot of people forget that. This negative needs to go on both of them. Okay. All right. That's all I got for you on that. This is just a review of all of those properties, which I think you've already got down. You are responsible for them. This next little thing is to just talk about how logs affect slide rules. How many of you have seen a slide rule before, like this, where this little piece slides out? You have a little reader thing on it. Raise your hand if you've actually seen one before somewhere in like a movie or something. Wow, we're down to only like 2 people. All right. In the movie, for instance, Apollo 13, they were launching rockets, and they sent men all the way up to the moon, went around the moon, and came back again. How many actually saw Apollo 13? It's the one, Houston, we have a problem. You know what I'm talking about? Okay. Anyway, in that movie, all of the engineer guys whip out their slide rules when they're like calculating stuff. Okay? And I just want to show you how that actually works. And it's kind of, I think I've seen an abacus. An abacus has little beads on little posts and they flip around. That's more of an Asian kind of a experience. Anyway, this is something that also can do calculating without a calculator. So this, I can't explain to you all of how it works, but I can show you just a little about how it works because it's logs at work. All right. You have 2 things sliding like this next to each other, okay? And they have this weird, what's called a log scale to it. If you've ever seen log graph paper, it's kind of annoying because the boxes are not all the same size, okay? And so there's a big gap here, and then there's a medium-sized gap, then it gets a little smaller, and then the gaps get smaller and smaller and smaller and smaller between the numbers. How is that at all like a log? Let me show you. Here's a picture of a log graph. How much it's rising? Do you get at the beginning of the log graph, from here to here, it rises that much? Do you get in the same amount of time from here to here, now it only rises that much? That's like, the first one is like this, and the second one, I'll do it in red. It only rises between here and here, and only rises that much. And that's like this gap. And then from here to here, it rises an even smaller amount, which I'll make this green again. Now it's down to only rising that much. Smaller amount. Do you get what's happening here? All right, they used that to make the upper and the lower parts of the slide rule. And here's what you do. If I line this up like this, think of this as a pointer. And can anybody see 3 times 2 equaling 6? I'm starting with the most basic multiply here. You see the 3 and the 2 lining up with the 6? Anybody? Okay, I'll help you. The 3 that I pointed at times the 2 makes 6. All right. How about 3 times 3 makes 9? Do you see that? Usually people catch on a little quicker now. 3 times 3 makes 9. All right, how about 3 times 5 makes 15? 3 times 5, here's the 5, makes, what's exactly between 1 and 2? 1.5, but this is the next notch up. So do you get when it goes 8, 9, that's actually 10, and then that's 20, and so what's exactly between 10 and 20? 15. So 3 times 5 makes, right exactly between 10 and 20 is 15. All right, So imagine for a moment that your job was to figure out what is 6 times 4. I slide this over and I make the pointer point up at 6. 6 times 4. You get how that's like between 20 and 30 and therefore 24. All right. And I know this is hard to get used to because you've never seen it before, but this was their calculator back then. They did not have a calculator. They'd have to go on paper work stuff out. So I'll make it just a little more intense. What about 2.5 times 2? Would you agree that I just aimed this at 2.5? 2.5 times 2 makes 5. This is 2.5 times 2 makes 5. How about 9 times 8 making 72? There's 9. This is pointing up at the 9 times 8. It's right there. Can you see it's a little bit more than 70? And if they had little fine marks on there, which they do in here, you'd be able to see it was 72. Or this one got a little intense last hour. 2.5 times 2.5. Okay, I move this to 2.5 times 2.5. Would you guys agree that it looks like it's a little more than 6? Because this is 2.5 right here. And then this should be 2.5. Should be a little bit more than 6, and I bet it is if you used a calculator. 6.6 what? Oh, 6.25. Okay, cool. And again, if you could read the little marks, here, I'm going to hand this thing around. You can try doing a little multiply. I encourage you to try something easy, like 2 times 3 first, and then see if you can figure out how to make like 2.5 times 2.5 work. All right. So it also has this little dude, which you can use to try to line things up. But I'll leave it to you now to try to learn how to multiply with a slide rule. Okay. All right. And that uses logs. How? Because this scale here is a log scale. All right. Moving on. Your homework for tonight. You know when you learn how to add, the teacher started with things like 2 plus 3. Eventually they moved to things like 2.5 plus 9.7, and it was a lot more complicated adding, right? Well, we have all the things we need. It's just the numbers are going to get weirder, and we can still use the same properties of adding, or in this case, properties of logs, just with more complicated numbers. So let's do first one is number 4. Do the number 4 together. Who notices what property I could use in this thing? The one where you could do what? If they're multiplied, then you can change it into add. So I'm going to put log 1.23 plus log 10 to the 37. But note, do you remember me telling you whenever they didn't have the base, it was going to be all about the base? Watch, when I put in the base 10, does anything change on the first one? No. But does something change on this one? Yes, you notice, oh, those are the same. So it's actually equal to what? 37. This whole thing is just 37. Do you actually have to notice that? Yeah, because it says expand it and simplify. That's part of the simplifying. And you know what usually gets kids? It's not the expanding, it's the simplifying. Okay, so you got to watch out for that by doing things like whenever you see ln, you change it to log base e. Okay, and how about square roots? They actually are powers. So that's really z to the 1/2. And that'll help because then you can go, oh, that's right. I can move the 1/2 down in front. because this will be log base e, because that's what ln means. Square root of z really means z to the 1/2, and then that 1/2 can drop down in the front here and be 1/2 there instead of there. All right, so that's expanding, and I just got the first couple started with you. I am going to let you skip number 15. I wanted to cross off something, but these two, even though I'd like to save you some time, they have some wonderful canceling that's going to happen, the simplifying. So remember that this is log base 10. Do you get how when it runs into a 100, it's really a 10 squared, that good things are going to happen with the canceling, simplifying? So anyway, those are going to be particularly good ones. Moving along, on this page, you may skip 28 and 29, but I think the rest of them are good. Oh wait, I did have people skip 22, just trying to save people some time here and still get you enough practice. All right, then on number 30, that one's a really tough one, and I do not need you to try to do that one. If you want to look through the key on it and figure it out and explain it to me, I'd love to have you explain it to me, because that's a really weird question. This one just asks you to change it to base 10. Do you remember if I gave you something like this, how would you change it to base 10? You'd go log 8 over log 3. And how is that really changing it to base 10? Because you can actually pick any base you want at that moment. Remember that? Same principle applies here. I will warn you that if you use the key, they do it a really weird way that I think might confuse you. But number 31, it does have the right answer on the key. It just does it in a weird way. Okay, number 45, you may skip. Unfortunately, I haven't got that scene to play for you, so every now and then YouTube will not, like sometimes you find scenes from movies there, sometimes they've been taken down, so anyway. And onto these, there's a few too many of them. I want you to do A, B, and C, and notice it wants the answer in terms of, which means you will have these in your answer, log B's and log C's. So that, how on earth is it going to turn into a log? That's your job to figure out with one more piece of advice for me. Again, you can skip that, you can skip the whole next page. So what advice do I have for you on that? Please watch. This is important. Do you get that in solving an equation, you can multiply by anything you want on both sides? Would you agree I can times both of these by 5 if I want to? Okay. Would you agree I could add 5 if I wanted to? Yeah. Would you agree I could divide by a variable if I wanted to? Like I could divide by x. Remember the kind you couldn't do that was when it was like this? But you can, because this is an equal sign, you could multiply both sides by x or divide both sides by x. One more tool in your math tool bag is you can put a log on both sides. But you want to do it strategically. You can put any base you want. Like for instance, I can log this side and log that side. By doing it that way, I didn't even write a base, which means I used what? Base 10. Do you get how I can put a log on both sides? If I give you the simplest of them all, if 5 is really equal to 5, then do you get that log of 5 will equal log of 5? Right? You can put logs on both sides. But since you can put logs on both sides, and you get to pick the base, what would have been a smart base to use? Log base 5. Do you get why that would have been smart? Because then this and this match up, and what did you just change the left-hand side of the equation into? Just x. X equals log base 5 of 20. Now you could just say, well, look at the black writing, Mr. Server. That's just rewriting it. Yeah, it is. It's just showing you a different way of why it works to rewrite it like that. So, moral of the story, you can take a log of both sides whenever you want. So if you have a to the b equals c, would you agree I can take a log of both sides? And which log base would be smart? Log base a on both sides, and that just becomes b equals log A of C. All right, that's going to be handy at some point. I just wanted to show it to you today. You still have many days of logs. It's one more tool you can do. Log both sides. Yes? Okay, I don't know which page that is. Is this one? You're skipping all that whole page. On this one, you're only doing A, B, and C, and I did give you a little hint. Okay. That's all I got for you for today. When the slide rule comes around, try multiplying like 2 times 3. If you can get that to work, move up to more advanced stuff like 2.5 times 2.5 or something like that.